the first lecture of this course, network analysis. And network analysis is an important course in the sense that those who are studying electrical or electronics, or for that matter any engineering discipline, it is a sort of fundamental course. And there will be about 60 lectures in which I will be covering this course, maybe a bit more. And I will start from the rather very initial stage of circuit analysis, quickly review those things which you perhaps already learned in your basic electrical technology course, but we will add some new flavors to those problems that you have already solved. In general, a network analysis problem is essentially that there will be a given network. A network will consist of several circuit elements like R, resistance, inductance L and capacitance C, and there will be a number of sources connected to that network. The problem at hand will be to find out the currents in various branches or power in the circuit, things like that. Therefore, very loosely speaking, a network essentially consists of elements like resistance, inductance and capacitance. These are circuit elements, and there will be sources which will energize the circuit, and these sources could be a voltage source or a current source, or both, or current source. So, a circuit will essentially consist of these circuit elements and sources like voltage source and current source. The voltage source is usually denoted by, if it is DC, it will be denoted by a battery like this, or if it is a large DC voltage, it will be denoted by polarities mentioned like this. This is how DC voltages are mentioned. Similarly, current source will be mentioned like a circle within an arrow, and besides it the magnitude of the current. These are the two terminals of the current source, these are the two terminals of the voltage source, like that. And similarly, here the voltage source could be a 10 volt battery or say 50 volt DC source. Sources could be also time dependent, it may change with as time passes. So, in that case it is said to be a time varying voltage. In case of DC sources, of course, with time the magnitude of the voltage or magnitude of the current source will not change, but still we can have a time varying sources like this, time varying sources can be, for example, a sinusoidally varying time varying voltage source could be represented by this sinusoidal symbol and it will be indicated like this Vt. Similarly, you can have a time varying current source exciting a circuit, and circuit consists of RLC. So, this in general we would expect these are the various components to be present in a circuit, and If the sources are known, if the parameter of these circuit elements are known, then I should be in a position to find out the currents. The essential thing to solve any circuit problem centers around two laws. One is called KVL laws, Kirchhoff's voltage laws, and KCL laws. Okay. And this is at the center stage to solve any circuit problem. KVL laws says that in any circuit, the sum of the voltages will add up to 0. Similarly, KCL means Kirchhoff's current laws, which states that sum of the current at a particular junction of a given circuit will add up to 0. We will come in detail what do I mean by this, but this KVL and KCL, if you know, and if you do not know anything, no new circuit theorems, interesting circuit properties, suppose I do not know, I know only KVL and KCL. What I am trying to tell is that with this knowledge, KVL and KCL, any circuit can be solved. Maybe it will become lengthy, it is not a very efficient method, but nonetheless these are the two laws which is used to solve any circuit problem. To give you an example, what I am trying to tell is this: suppose you have a simple circuit like this, DC circuit, suppose a simple circuit like that. Suppose the voltage is this one, and this is suppose 6 ohm, this is suppose 4 ohm, and it has also got some simple circuit. With that I will try to explain what do I mean by this. So, the equivalent resistance 6 ohm and 4 ohm, they are in parallel, it will be 6 into 4 by 10, that is 2.4 ohm. And this is suppose this resistance is suppose 0.6 ohm, and here is 30 volt the sources. So, I have been asked to find out the currents. Now, in this circuit it is 2.4 plus 0.6, that is 3 ohm. So, this current will be 10 ohm. These we know from school days, that is these two are in parallel, then this is in series. So, 2.4 plus 0.6 is 3 ohm. So, this current will be 10 ampere, and then this current will be, these two are in parallel. So, the total current into 4 divided by sum of these two resistance 10, is not total current. If you want to find out this current, then that other resistance divided by sum of these two. So, this will become equal to 4 ampere. Similarly, this current will be the total current into the other resistance 6 divided by 10, that is to be 6 ampere, is not. If I solve this circuit from the knowledge of series, parallel, resistance and so on. Therefore, after you have solved this circuit, I know the currents in all the branches and all the parameter values are known. Of course, here I have considered only resistances, it does not matter, we will see later. Now, the question is, what is the voltage drop across this 0.6 ohm resistance? I into R is the voltage drop. So, I will write down the voltage drop as this is plus, this is minus, because current is flowing from left to right, and the magnitude of this voltage will be 0.6 into 10, that is 6 volt, is not? This will be this. Similarly, voltage drop across this resistance will be 4 into 6, that is plus minus. This plus minus is put knowing the direction of the current here, and this will be 24 volt, 24 volt. Similarly, the voltage drop here in this branch will be 4 ohm and 6 ampere is flowing. This is also 24 volt. This will be the situation. So, I have solved the circuit. Now, first of all, Kirchhoff's current law, let me see whether it is satisfied. This is 10 ampere coming and 6 ampere is flowing here and 4 ampere is flowing there. So, this is 4 ampere and this is 6 ampere. So, Kirchhoff's current law is satisfied at this junction. Similarly, at this junction it is 4 ampere there, this is 6 ampere there. So, 6 plus 4, 10 ampere there. So, it can be found out in a very simple manner. So, KCL with the help of this simple example, we know what does it mean. That is, whatever total current coming in, that must be equal to the sum of the currents leaving the junction. Now, what about KVL? KVL says that consider any closed path in the network and the sum of the voltages, if you add up, that will sum up to 0. For example, consider this loop, this closed path. Now, after identifying the closed path, what I will do is this, I decide to start my journey from this point and I will traverse this closed path in this direction, does not matter. Suppose I decide I will go this way. So, from this to this, if you go, there is a 30 volt voltage rise. So, I suppose I decide to assign a plus sign to this. So, I have reached from this point to this point. Then I will go from this point to this point. In this path there is no voltage drop, no voltage exists. So, only 30 volt we have encountered. Then from this to this if you go, there is a 6 volt appearing across this 0.6 ohm resistance, and this 6 volt is from plus to minus. So, I will put a minus 6 here, is it not? So, minus to plus I have assigned plus, then plus to minus I have assigned minus 6. Then I have reached this point, here there was no drop. So, from this to this if you come, it will be once again from plus to minus. So, minus, and this voltage drop is 24. Now, if you sum it up, it is equal to 0. So, this is KVL in this closed loop. Similarly, in this loop it is so simple, you start from this point, from this to this if you go, minus to plus, plus 24 volt, then plus to minus, minus 24 volt, and that is 0, and you reach this point. So, after you sum up this voltage from this to this, you have to come back to the same point, that is essential. So, here there is no voltage drop, that is why no other terms existed here. It is also true for this loop also. Suppose the closed path is chosen here, this bigger outer loop. Any closed path, KVL law says that algebraic sum of the voltages appearing across the sources or circuit elements must add up to 0. So, suppose in this outer loop, if you start from this to this point, it is 30 volt, then from this to this plus to minus 6 volt, then I have decided I will not go this way, but this way. Then from this to this, if you go, it is minus 24 volt. So, you have reached this point and you have decided to come back here, forming the closed path, and that also amounts to 0. So, this is KVL. Therefore, this is in nutshell KVL and KCL is all about, that is, however complex the circuit is, it will consist of several closed paths, and the voltage drop across all the elements including the sources, if you add up, that will add up to 0. Similarly, whatever junction you take, the whatever current is coming in will be equal to whatever current is leaving out that particular junction. And knowing this, any circuit can be solved, KVL and KCL. Acha, because I have drawn this circuit, I will also tell you another important thing. With reference to this simple circuit, which consists of only resistance and a fixed DC voltage, we have explained KVL, KCL. Another thing I will explain, that is, these are circuit elements. Sources can be also considered to be circuit elements, but capable of delivering power into the circuit. So, this is one element, source element, these are elements, okay, fine. Now, in this circuit, let us do some power balance thing. What does it mean? Remember, any circuit elements, therefore, we have learned that any general circuit elements, it may be resistance, inductance or capacitance. Let me put it in a box, and suppose you calculate the voltage drop existing across that particular element. If you find a situation exists like this, voltage drop polarity is like this, and it is its current direction is like that, then I will say that this particular element is delivering power. That is what happens in a battery in general. So, this box could be a battery, could be a resistance, could be inductance, capacitance. We will go into detail, further detail into that, but in general, okay, if there is an element, if you have managed to calculate the voltage existing across that element with the polarity, correct polarity, and you have also managed to solve the current flowing through this particular element, and you find the current direction is like this, then I will say that this element is delivering power, delivering power whose magnitude is V I. That is what I will tell. If it so happens that there is a circuit element which could be anything, either R, L, C or a source, if you find that the voltage across the element is like this, this polarity, polarity is important, and current is entering through the positive terminal of that particular element, then I will say this element is absorbing power. And the value of this absorbing power will be this voltage with this polarity into I. That is the thing. Got the point? So in a circuit there will be elements, there will be sources connected. Suppose I have solved the circuit, for example, with reference to this simple network, I know all the currents, I know all the voltages existing across each elements including sources, then I will be able to identify which of these, how many elements are there, 1, 2, 3 and 4. This is a source, another element in the circuit. So, what the battery is doing, is it absorbing power or delivering power? Suppose I want to examine. So, I come to this battery has got these two terminals. These are the two terminals of the battery, and what is the current? Current is flowing like this. How much is the value? 10 ampere. So, what the battery is doing? It is delivering power, because this is the element, voltage across it is plus minus, and through the plus terminal 10 ampere is coming out. So, battery is delivering power. And what is the value of this power? 30 into 10, voltage into current. This situation, it is delivering power 30. So, it is delivering power 300 watt. Got the point? Now, where this power is going? This power, whatever the battery is delivering, is absorbed by, expected to be absorbed by these three resistances. So, let us see power in this 0.6 ohm resistance. What it is? Is it absorbing or delivering power? Voltage drop across it is, this is plus, this is minus, this is 6 volt, and current is entering 10 ampere through the plus terminal like this, and therefore, this must be absorbing power. So, what is the value of this power? Voltage across the element 6 into 10, is not, that is 60 watt, which happens to be equal to, this is also equal to I square into 0.6. I square R is same as V I, because V equal to I R and so on. So, power absorbed by this 0.6 ohm resistance is this. Power absorbed by the 4 ohm resistance. So, this is absorbed, mind you, absorbed. 4 ohm resistance also absorbs power. Why? Because the voltage across it is 24 volt, with this is plus, this is minus, and 6 ampere is entering through the plus terminal. Therefore, through this 4 ohm resistance, power absorbed is 24 voltage across it into 6 ohm, 6 ampere, sorry, and it will be equal to 144 watts, is it? This will be the power absorbed by 4 ohm. And what about power 6 ohm, this resistance? does this 6 ohm delivers or absorbs power? It absorbs power because voltage across it is this is plus, this is minus, and current is entering 4 ampere through this. Therefore, this also absorbs power, and the value of that power is this into 4, and this is equal to 96 watt. Therefore, this also absorbs power and this element also absorbs power. So, total power absorbed will be equal to 60 plus 144 plus 96. And if you sum this up, this is going to be equal to 300 watt. So, 300 watt. So, the point to be noted is this: in any network, however complex it is, with time varying voltage source, with RLC, all things are present, KVL and KCL rule has to prevail, they must be satisfied at all times, and also the power balance must be also true at all times. This is the one of the very fundamental thing I must tell you. No matter how complex the circuit is, whether the sources are time varying, whether R, L, C are present with sources time varying, at any given time t, if you know the instantaneous voltage drop across all the elements and instantaneous value of the currents in all the elements, this power balance must prevail, along with the fact that KVL and KCL will be satisfied. Okay. So, with this simple example, I have explained to you various important things, which we will take up in detail in next few lectures, that for a given network, the conclusion of today's lecture is, for a given network, no matter whether it is only containing R or RLC, or whether it is an electronic circuit with transistors, op amp present, there will be sources and all the circuit elements if you know, and suppose somehow you have managed to find out currents in all the branches, then be rest assured that KVL in any closed path is satisfied at all times, that is very important. KCL at any junctions will be satisfied at all times, and power balance must be satisfied. That is, there will be some fellows in the circuit, primarily the sources, which will deliver power into the circuit, and that power will be absorbed by different other elements in the circuit. We will see in the next class also that there will be circuits where it is not true that sources will always deliver power. There may be situations when sources too will absorb power. Those things we will take up in the next class. Thank you.